Recording started.
Okay, so I'm going to go ahead and get started. Sharing my desktop so you can see. And there we go. Okay, so on your screen should be an MAT 115 Logic webinar message, and we're going to go ahead and get started. And like I said, this is being recorded, and periodically I'll pause to see if there are any questions along the way. And the objectives of what we're going to be discussing this evening, we're going to translate from words to logic, symbolic logic. We're going to construct truth tables, determine if the statement is true or false, and determine if statements are equivalent. We're going to start with some symbols. The first symbol is a negation symbol. The negation of a statement is the opposite truth value, and the symbol looks like, I just call it a little squiggly mark. An example, the Earth has 2 moons. The negation of that would be the Earth not have 2 moons. So if you notice, it changes the truth value when you do the negation. The negation of a false statement is true. The negation of a true statement is false. So I'm sorry, if you have a phone that is not on mute, please mute your phone because there's a lot of background noise that's getting in the way. I'd appreciate that. Thanks. If we let P represent the Earth has 2 moons, then the negation of P would be the Earth does not have 2 moons. And in this case, P is false, so the negation of P is true. And in general, if P is false, the negation of P is true. And if P is true, the negation of P is false. So a basic rule to remember when dealing with negation is that they have P and the opposite of P, like the negation of P have opposite truth values. It's just something to remember when dealing with that symbol. Okay, so conjunction, this is a connective in a compound statement that means both. And the symbol looks like an upside down V. An example would be, this is easy and I will earn an A. The word and is joining the 2 parts. This is easy. This is easy is the one part. I will earn an A is the other part. So if we let P represent this is easy and Q represent I will earn an A, the sentence is P with the conjunction symbol and Q. So if you notice, we're taking a sentence and we're translating it into symbols, letting the variable, think of it as variable P and Q, represent part of the sentence. Okay, so the only way for this statement to be true is if it is both easy and you earn an A. Because if it's easy and you earn a B, that sentence would be false. If it's difficult, then of course that sentence is false, even if you earn an A. The only way for this to be true is if it's both easy and you earn an A. That's the only way for that statement to be a true statement. So if either part is false, then you say the statement is false. So a rule to remember with the conjunction is that it's true if both parts are true. Otherwise, the statement is false. So far we have 2 rules to remember, and we're going to have a total of 5. So we're moving along here. Disjunction is another rule. It's a connective and a compound statement that means one or both. And it's a symbol that looks like the letter V. So here's an example. This is easy, or I will earn an A. The or joins the 2 parts. This is easy, that's one part. I will earn an A is the other part. So if we let P represent this is easy and Q represent I will earn an A, the sentence this is easy or I will earn an A translates to symbol form like that. So we're taking this sentence and translating it to symbols. Now, when is this going to be true? Well, if it's easy but you earn a B, the statement is still true. If it's easy or I earn an A. So if it's easy, it's true. If it's difficult but you still earn an A, it's true because the second part of the or would be true. If both parts of the or are true, where it's easy and you earn an A, then it's true. The only time this would be false is if it's not easy and you did not earn an A. So that means both parts of the or have to be false for the statement to be false. So we put that in our rules to remember with disjunction. The statement is false if both parts are false. That's the only time it's false. Otherwise, the statement is true. So for the disjunction, now we have a rule. Let's move on to another symbol. The conditional is where it's a connective in a compound statement that provides the condition under which the part after then will be true. It's called a conditional because there is a condition to start with, and then there's the part after the condition. Okay? So, and the symbol we use for that is a arrow. An example would be, if this is easy, then I will earn an A. So the condition would be that it's easy. The if-then joins two parts, it is easy, and the other part, I will earn an A. So if we let P represent this is easy, and we let Q represent I will earn an A, the sentence would be translated into symbols looking like that. So here's our example sentence translated into symbols would be P, arrow, Q. This is easy is considered the condition. So if the condition's met, what comes after the then should be met as well. So if this is easy, then the statement means you will earn an A. So in that case, it would be true, right? If you have, it's easy, you earn an A, you have something that's true. But let's say the condition is met, but you don't earn an A. So it's easy, but you earn a B. That Hello? Hi, I was hoping that you'd be able to hear me. I don't know what happened. It just said I left the meeting for a minute. I apologize if I was temporarily silent. I believe I'm back in. Okay, so we're talking about the conditional, and where if it's easy, then you will earn an A. So if it's easy and you earn an A, that statement is true. But what if it's easy and you earn a B? Then that would be false. That would be a false situation. So that's a problem. But what if, so if you have it's easy and you earn an A, it's true. If it's easy and you don't earn an A, then the original statement is false. But what if it's difficult? How can we determine anything about the grade? We really can't determine anything about the grade at that point because the condition has not been met. So the statement that says, if it's easy, then I will earn an A, I don't have any justification for saying that's false if it's not easy. So we mark the statement as true if that's the case. If the condition is not met, it's considered a true statement because we have no justification for saying the statement's false because we don't have the condition met to deal with the result of the condition to see if it's false. So the only time a conditional is false is if the condition's met, but what comes after the then doesn't happen. So the rule to remember for conditional would be the statement is false if the condition is true, but what comes after the then is false. That's the only case that this would be false, is if the condition's met, but what comes after the then is not met. Otherwise, it's considered a true statement. So if you have true, arrow, false, this is where the condition is met, but the result is not. That would be considered a false situation. Okay? Otherwise, it's true. So now we have the fourth rule for the to help guide us. We're going to move on to the last rule, last symbol that we need to translate, and we'll start looking at truth tables. It's a biconditional, and this is a connective compound statement using if and only if. That means both of these things. It means if P, then Q, but it also means if Q, then P. Both of those things, and the symbol shows the arrow going both directions, meaning that it's both statements, if P, then Q, but it also means if Q, then P. An example would be, this is easy, if and only if, I will earn an A. What the statement means is if this is easy, then I will earn an A. If I earn an A, then this is easy. It means both of these things when you say if and only if. So let's say we have P represent this is easy, and Q represent I will earn an A. So the sentence is P and then the double arrow symbol, Q, which means P arrow Q and Q arrow P. When you write it like this with the double arrow, it means it goes, the arrow's going both directions. So, and this is a conjunction, see the word and right here. So it's only true when both conditionals are true. If P arrow Q is true and Q arrow P is true, then we can say the biconditional is true. So if you have, now we're dealing with the conditional here, P arrow Q, Q arrow P. So we have to go back to the rule for conditional to figure this out. The rule for conditional is it's false when you have this situation. Otherwise, it's true. So when will we have T arrow false? Well, if P is true and Q is false, then that would be true arrow false. So that would be false right there. If P is false and Q is true, then the one going that direction would be false. So the one with the double arrow would be false. So P, basically the bottom line here is that if P and Q are opposite truth values, you're going to end up with a situation of T arrow false. If they're opposite truth values, you're going to have this situation happen. So the biconditional is false. What if P and Q are the same truth values? Well, if P is true and Q is true, then the conditional P arrow Q is true, the conditional Q arrow P is true. So if it's all true, then this is also true. Okay, so if they're the same, where I have true, true, then the double arrow is true. What if they're the same where it's false, false? Well, the conditional rule is that false arrow false is marked true. So when you have that here and you have that here, that's true. So that means that the biconditional is true. So the rule to remember for biconditional is that when both parts are the same, it's true. But if if the P and Q are different truth values, it's going to be false. So basically what we've done is taken the 5 symbols and come up with a rule to remember for each of them. So instead of memorizing or studying truth tables that go along with each of these symbols in logic, it's better to just remember the rules and work with the rules and keep a copy of them handy when you're working on logic assignments. So here is a summary of all 5 rules in case you've missed something. And like I stated before, this is being recorded. So if the slides are going too fast, you can always, for you to write everything down, you can always go back to the recording that's going to be sent out, and then you can press pause whenever you want to. But these 5 rules here summarize symbols. If you need to mute your phone, please do so there's not a background noise. If you're on the phone and it's not muted, can you mute your phone? So we have the five rules that we're just going to keep referring to as we're working forward, working problems. Okay? So just a little recap here. Negation is the opposite truth value. The situation with the conjunction is that it's true if both parts are true. Otherwise, it's false. The disjunction, it's false if both parts are false. Otherwise, it's true. The conditional is false if you have this statement, true, arrow, false. Otherwise, it's true. Biconditional, true if both parts are the same. Otherwise, it's false. So this is a good little summary to have handy when you're working the problems that we're going to be working. I'm going to keep referring to these. Okay, so let's do some examples. An example of, let's say we have P is true, Q is false, and then I have this statement here, negation P, conjunction Q. So I need to know, is that true or false? Well, since P is true, negation P is false. So this is actually false, conjunction, false. And so now we have to refer back to the rule for conjunction. It's only true when both parts are true, otherwise it's false. So since we have false, false, the answer is false. And I knew that was the answer because I referred to the rule for conjunction. Okay, so let's do another example. Let's say P is true, Q is false. Is this statement true or false? Again, we have negation of P, and then we have P and Q. Now notice we have 2 operations here. We have the disjunction and we have the conjunction. And just like when working problems in algebra or numbers, you have to do what's inside the parentheses first. So where I'm going to focus is right here with P, disjunction, and the Q. So I know that Q is false and P is true. So inside the parentheses, we have that, which is false, disjunction, true. So in order to figure out the truth value of what's inside the parentheses, I have to refer back to my disjunction rule. And the disjunction rule says it's false when both parts are false. So I don't have that situation, so that tells me what's inside the parentheses is true. So I have now negation P, conjunction, and to the right of the conjunction is true. Now I know that P is true, so negation of P is false. So the problem is now false, conjunction, true. And to figure out the answer, I have to go back to the rule for conjunction that it's only true when both parts are true. And we don't have that here because we have a false part, so the answer is false. But notice I worked it in pieces. I started inside the parentheses first, find out that truth value, and then move on to the conjunction. Okay, another example. If P is true, Q is false, and R is true, is this statement true or false? Notice I have two sets of parentheses. So again, I need to start with working inside the parentheses first. I notice I have some negations here. Well, since P is true, negation of P is false. Since Q is false, negation of Q is true. So when I put the truth values in, notice I'm taking out the P's, the Q's, and the R's, and I'm putting in P's and F's for true and false in order to evaluate the truth value of the statement. So I put the true, false in there, put the true, those are both truths. And when you work inside the parentheses first, we have conjunctions in both of them. We have to refer to the rule for conjunctions, that it's only true when both parts are true. So inside the parentheses in the first one, I don't have both parts true, so that's false. Inside the second one, I do have both parts true, so that's true. So in the first parentheses, I have false. In the second parentheses, I have true. And in between the parentheses, notice I have a disjunction. So now I'm ready to work with that symbol now that I know the value of what's in the parentheses. And the rule for disjunction is that it's true unless both parts are false. So the answer for this problem is true. Okay, let's work another example. Let's say P is false, Q is false. Is this statement true or false? Well, we have a lot of negations in there. If P is false, negation of P is true. If Q is false, negation of Q is true. So when I put the T's and F's in the sentence, it looks like this. And just like with the last problem, we need to do what's inside the parentheses first. So I work inside the first set of parentheses. I have true, arrow, true. And I have to remember my rule for conditionals. Rule for conditionals is that it's true. My rule for conditionals is that it's true unless I have this situation. This is the only false situation for conditionals. Everything else is true. So inside of the first set of parentheses, it is true. T, arrow T is true. Second set of parentheses, I have the false situation. So with my biconditional, that's the double arrow, to the left, I have true, and to the right, I have false. This T is because of what's inside the first set of parentheses was true. This F is because of what's inside the second set of parentheses was false. now I'm down to the biconditional. And the rule for the biconditional is that it's true when both sides are the same. Otherwise, it's false. So we don't have both sides the same here because one is true, one is false. So my answer to the problem is false. And so far, we've been dealing with situations that we are told the truth value of P and Q in order to see, what the answer was. But what if we're not told the truth value of P and Q? Then what we're going to need to do is list all the possibilities. So as an example here, we're given another statement, but we're not told the true or false value of each of those P's and Q's. So we need to come up with a list of possibilities. Now, when you list the possibilities, the general way of doing things, standard, I don't know, people do it this way all the time, where P is true, true, false, false, and Q is true, false, true, false. It's just always, if you just always do it like that, then you know you don't miss any possible combinations, like the first row is true, true, second row true, false, third row false, true, fourth row false, false. So you can see that we have in that list every possible combination of P and Q. So for P, we put true, true, false, false. Q is true, false, true, false. Okay? And we have some negation of P up here. So if P is true, then negation of P is false. If P is false, then negation of P is true. Okay, so what we need to do is we're going to use this example and have to work with all of these possibilities. So what it's going to look like is this, where you have all the possibilities listed with the example. So here's in yellow the possibilities, and then the example that they're asking us is right there. And notice what I did underneath. P is true, true, false, false. So here's my negation of P, false, false, true, true. Q is true, false, true, false. So in my Q column, I wrote true, false, true, false. And here's negation of P again. P is true, true, false, false. So negation of P is false, false, true, true. Okay? Now, just like before, we need to work inside the parentheses first. So I'm going to be focusing on the Q disjunction negation P. That is where I'm going to start. And because it's disjunction, I have to recall the rule for disjunction, which is true unless both parts are false. So I'm going to have that rule in my mind as I'm looking down this column, the disjunction column, to see what to write for each row. So when I look down here, I see the first row is true, disjunction false, so I put true because I'm following the rule for disjunction. The only time it's false, it's true unless both parts are false, right? So the only time it's false is when you have false, false. Notice that I do have one case right here where both parts are false, and notice that's the only time I put an F in the disjunction column. All the other times I put true because either one or both of the parts was true. So what this gives me now is that just like before, we needed to find the truth value of what's in the parentheses. Here, this column right here that I just circled is the column that tells me the truth value of what's inside the parentheses. So now I can move on to the last column, which is right here. It's the conjunction. And To the left of the conjunction is the negation of P. To the right of the conjunction is the value of what was in these parentheses. So I have highlights of them in blue that to the left of the conjunction, I look at this blue column. To the right of the conjunction, I look at this blue column because that tells me the value of what's in the parentheses. And I follow the rule for conjunction. The rule for conjunction states it's only true when both parts are true. So if you look in the first row, I have false, true. So that's why there's a false in this column right here. Second row, false, false. So that's why there's a false. Third row, true, true. So I was able to write true because that's the case. When both parts are true, you can write true. And again, here in the last column, last one, true, true. So again, in the conjunction column, I wrote true. So I go through each row following the conjunction rule to tell me what to write. Okay, the last column we complete is the one I have the arrow drawn above it. Okay, this tells me the last column is false, false, true, true. So that tells me the first two rows result in a false statement, and the last two rows result in a true statement. So there are two ways for the statement to be false and two ways for the statement to be true. It just depends on the values of P and Q. So if we go back to the first row, P is true, Q is true, that would end up being a false statement. Second row, P is true, Q is false, that would be a false statement. Third row, P is false, Q is true, that's a true statement. Fourth row, they're both false, it's a true statement. So that tells you like the different possibilities for P and Q and whether the result would be true or false. Again, when we filled in the table, we did what's inside the parentheses first and followed the rules that go along with the symbol we're looking at. Okay, let's do another example. Find the possible truth values for this statement. Notice I have the same possibilities listed where P is true, true, false, false, Q is true, false, true, false. So if Q is true, negation of Q is false. If Q is false, negation of Q is true. And I'm doing that because we do have a negation of Q in this problem. So we're going to do the same thing as before and list the possibilities with the example right next to it. So there's the same list of possibilities in yellow, and then here's the example that we're dealing with. And notice again, I just went ahead and filled in the columns for P, true, true, false, false. So under all the P's, I wrote true, true, false, false. Under the Q, I wrote true, false, true, false. Under negation of Q, I wrote false, true, false, true. So we have those filled in. Now we need to work inside the parentheses first. So let's look at the first set of parentheses. It's the conditional. So we're going to have to refer to the rule for conditional is that it's true unless we have true arrow false. So using this rule, we fill in the conditional part of the table. Notice the only time I wrote false is right here because that's the situation where you have true arrow false. All the other ones are true. So that column is telling me the truth value of what's inside those parentheses. Next, I'm going to do the other set of parentheses. Second set of parentheses has a conjunction symbol. So we have to remember the rule for conjunction, refer to that. It's nice to have these rules like written down on a piece of paper next to you as you're working these problems so you can just keep referring to them. The rule for conjunction is it's true only when both parts are true. Otherwise, it's false. So notice when this column is filled in, I wrote true when it's true, true. All the other ones are false because that's the second row is the only one that there's a true situation, following the rule for conjunction. Okay, notice we only have one more column left, and that's the biconditional. We're going to be using the rule for biconditional to fill that in, and we're going to use the truth value to the left is what's inside parentheses on the left. The truth value to the right is what's inside the parentheses on the right. And I've highlighted those columns in blue so you can see which columns we're using to evaluate the last column, which is the biconditional column. So we have to remember the rule for biconditional, and that it's, if both parts are the same, it's true, otherwise it's false. So we have to look like in the first row. The first row I have true, false, so that's why there's a false there. Second row, false, true, so that's why there's a false there. Third row, true, false. Fourth row is also true, false, so false and false again, because I don't have any situations where both sides of the biconditional are the same. So what ends up happening with this one is the last column I fill in ends up being all false, because I don't have a case where both sides of the conditional are the same. So this tells me that no matter the truth values of P or Q, the statement will never be true. It will always be false. Kind of interesting. Okay, so we've done some examples with P and Q and making a table listing the possibilities, but sometimes we're going to run across problems where they give us 3 letters, P, Q, and R. So I'd like to take a look at an example with P, Q, and R. You need 8 rows. Every time you have P, Q, and R, where you have 3 letters, you need 8 rows. So here's our example. We had to come up with a different list of possibilities because we have 8 rows, we have P, Q, and R. Here's the general way of doing things when you're trying to fill in the 8 rows, okay? Notice that with P, I did 4 trues, 4 false. Then with Q, I do in groups of 2, true, true, false, false, true, true, false, false. And then with R, it's every other one, true, false, true, false, true, false, true, false. If you do it like that, you're going to get all the possibilities and not miss anything. So the P's are in groups of 4, the Q's are in groups of 2, and then the R is just every other one. And if you just do that every time, then you'll get all the possibilities and not miss anything. But you have to make sure you have the 8 rows. So what we're going to do with this is just like before, write the possibilities and then the example, okay? And we have a negation of R. So if R is true, negation of R is false. If R is false, negation of R is true. So if you notice in the negation of R column, it's the opposite of R. And then the P column, just brought that over, 4 true, 4 false. The Q column, so there's the P column, there's the Q column, just bring over the true, true, false, false, true, true, false, false for the Q column. Just like we've dealt with in the past, we have to do what's inside the parentheses first. So I'm going to be handling this first. And it is a disjunction. So again, I refer to the rule for disjunction, which means it's true unless both parts are false. And I'm going to use this rule to fill in that column. So that's where I get this true, 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 false, 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 true, false, true. When I fill this in, I'm looking to the left and the right of that blue column, and I see that I'm following the rule that I write true unless both parts are false. okay? So that blue column now is telling me the truth value of what's inside the parentheses, which is what is to the left of the conditional. So there's one more column that needs completed, and that's the conditional column. So we have to refer to the conditional rule, is that it's true unless you have a T arrow F, then it's false. So using this rule, we're going to complete the conditional column, and the two blue columns are the ones I'm looking at. To the right of the arrow, you have the Q. To the left of the arrow, you have the value of what's inside the parentheses. And so following the rule that the only time I write false is if it's true, arrow, false, which did happen here, here, and here. Otherwise, you write true. All these rows are the true, arrow, false rows. That's when you write false. Okay? Otherwise, you put true. So the last column I filled in is basically telling me the possibilities for that particular statement. And I have them listed over here. This is the last column we filled in. There's the three possible ways for it to be false. So there's 5 ways for the statement to be true, 3 ways for the statement to be false. It all depends on the truth values of P, Q, and R. Okay, so that's how you fill in truth tables, whether you have P and Q or if you have P, Q, and R. The last thing I'd like to look at today is how can we determine if statements are equivalent? Well, equivalent statements have the same truth value for every possible situation. So what we do is make a truth table for each statement, and if the truth tables and result are the same, then they would have the same truth value for every possible situation. So let's take a look at these two. There's this one and this one. And at first glance, you may say, oh, those have to be equivalent because it kind of looks like they took the negation and distributed it across the parentheses, okay? Well, I don't know if that's a valid move or not because a negation symbol in logic is not exactly the same thing as a negative symbol in just dealing with numbers. So let's see if this is a valid move, because if these are equivalent, then that means you're allowed to do this and that they're the same thing. But if we end up with different truth tables as a result with these two, then that means you can't just take that negation and distribute it across the parentheses, okay? So let's start with the first one, which is negation P with the disjunction symbol and Q. So I filled in the P column, filled in the Q column, and as usual, we have to work inside the parentheses first. So I'm just going to be looking at the P disjunction Q, and we're going to need to follow the disjunction rule, is that it's true unless both parts are false. And we do have a situation at the very end where both parts are false. Otherwise, it's true. So what we have now is this is the value of what's inside the parentheses. And if what's inside the parentheses is true, negation of true is false, because we have this negation symbol in the front. If what's inside the parentheses is false, the negation of false is true. So we're going to use this information to fill in the last column. So inside the parentheses, the truth value I have highlighted in blue, and then the negation out in front is the opposite of that column. And since this is the last column I filled in, that's the column that tells me those are the possibilities for the statement. You always look at the last column you fill in to say, this is my answer for this truth table. These are the possibilities for this statement. So the first 3 combinations of P and Q would be false, and then at the end, that would be true. Now, if we get the same result for the other statement, then we know that they really do say the same thing. If not, then they don't. Okay, so we're going to do this with the second statement now. We have a negation of P column. We have a negation of Q column. And so if P is true, negation of P is false. If P is false, negation of P is true. If Q is true, negation of Q is false. If Q is false, negation of Q is true. And so I use that information to fill in the columns. And now I just need to fill in the last column, which is that column right there with the disjunction. And to do that, we're going to follow the rule for disjunction. And that the rule is it's true unless both parts are false. So I use that rule to fill in my last column here. To the left, I'm looking at negation of P. To the right, I'm looking at negation of Q. And I notice my last column looks like this. That is not the same thing that we arrived at with the other truth table. So it's not the same list. They do not have the same truth values for the same situation. So they are not logically equivalent, which means this is not saying the same thing as that. So you cannot just take the negation and distribute it across the parentheses. It doesn't work that way with the logic, okay? So let's say we have let P represent it rain today, and Q, it is cold outside, just to see what this would be like in sentence form. The first one would say, it is not true that it rained today or is cold outside. The second one says, it did not rain today or it is not cold outside. So what that's saying is those two statements do not mean the same thing. They sound alike, but they're not logically equivalent because they don't have the same truth values in the end, so they're not saying the same thing. They don't mean the same thing. You cannot just interchange those two sentences. Okay, just a little summary of what we've talked about this evening as we wrap up, that these are the 5 symbols that we translated into logic statements. We had a rule to go along with each one of them. We determined if the statement is true or false by using the list of rules for those 5 symbolic logic symbols. We also constructed truth tables following those rules as well, and also determined if statements are equivalent by constructing truth tables to see if the end results are the same. So that's basically what we covered this evening. Are there any questions? I do have an email address listed there in case you want to email me your questions. I just also wanted to make a disclaimer. I guess the teacher in me has to say this, that this 1 hour or whatever webinar is not intended to cover the entire chapter on logic, okay? So that's just because you listen to this video, that doesn't mean you're good, you don't need to read the book, because I could not possibly cover everything in the logic chapter. So I just wanted to make that statement just to encourage you to still take a look at, the book and what they have in there. Okay, so I'm going to see what kind of questions we have in the Q&A section. Let me pull that up for just a minute. Okay. I see lots of questions. What if both statements are false? I see a question about that. Yes, you're supposed to be able to hear this. Sorry if you did not hear this. There's a way to call in on your phone to connect to audio. What if both statements are false? I'm not sure what that's referring to in your question. So maybe if you could clarify that. It just depends on the rule that you're looking at. Like if you're looking at the disjunction or the conjunction, it depends on which one you're meaning. Like if it's a biconditional or a conditional, If both are false, if the left side and the right side are both false, then you have to go by what the rule says as to whether it's true or false. I hope that answered that question. Are there any other questions? You can type in the Q&A box. Oh, you're good now? Okay. Okay, good. I'm glad that I was able to answer your question along the way. Okay, are there any other questions that if so, you can go ahead and type that in the Q&A box, or you can type it in the chat window. Okay, well, again, thank you so much for attending. This is being recorded, and I will send out the information to listen to the playback in case you want to hear it again. And for those who were not able to attend this evening, be able to listen to the recording of the webinar on logic. So go back to my information here real quick, sharing my desktop, but it's not showing up. There it is. Okay, so if you have any other questions, feel free to email me. And thank you so much for attending this evening and learning about logic.